Welcome back to the UGC lecture series on lasers. Now, we are going to see another important application of laser, a unique application of laser that is called holography. The very word graphy, it is a representation on a paper on something else. That is what we are familiar with this seeing the graph, trying to understand. This is a holography, which means literally it means it is a complete picture, that is all it means literally. Now, this is a special type of 3D lensless photography. That is a proper description of holographic images. In this case, you employ a laser and try to record the amplitude and also the phase of the wave that gets scattered from an object. Look at this one, the frequency is the same, we are not going to change, but we are going to change only the amplitude and phase, because we are going to use a light, particularly a laser light, that is not going to get changed by the object. First thing you must remember, when it falls on an object, the scattered light that comes back has a certain change in the amplitude and also in the phase. Then if you could preserve it, you would have done the first part of the holographic technique, which is called construction of a holography. Then the second part is the reconstruction of the holoplate. It needs 3 steps. First thing, use a laser, have an object, have a specially prepared holographic plate, then do the first part of this one, construction of a hologram, that is something like taking a photo. Then if you have taken photography in your olden days 50 or 60 years ago, if you just ask the photographer to click, in those days there used to be a plate. Then if you ask your photographer, show me the plate, show me how beautiful I am, how handsome I am, he will say, don't ask me, I cannot show you now. I have to take the plate, go to a dark room, put it in a specially prepared chemical solution, then the chemical will do certain reaction on the photo plate. Only after that you will be able to see how beautiful or how handsome, what is, are you smiling, or you are crying, whatever you want to see, you can see only after the particular photographic plate got reacted with a certain photochemical material. So, in the olden photography, you have a camera, you have an object, click, that is the first step. Then take the plate, go to the dark room, do the processing and come back, you can show. Here the more or less same, there is only one difference. You have an object, instead of a camera you have a laser, shine the object with the laser. Then you have the construction, then take the plate, process it. Third step, put the plate the same place where object was there, in the same place where the plate was there, then shine the laser alone, then you will see the 3-dimensional object projected in the space. Now, let us go back. This particular type of holography has something really funny. This is called lensless photography, first thing. Secondly, this is a complete photography. Third one, the most interesting thing is, if you take a holographic plate, after all this process, take the plate, it will be usually a glass plate in which certain chemicals is coated, something like very similar to whatever the conventional photographic plate we had. And then if you can break it, you can easily break it, you just drop it, it's a glass plate, it will go into pieces. It will go into 10 pieces with the irregular shape. Then take any one of the pieces, even one piece will be able to reconstruct the complete image. How and why? This is something fantastic. That is what we are going to see. All these put together is a totally new type of photography, and this one Nobel Prize. It deserves certain Nobel Prize because this is something totally unexpected, unbelievable, but all these were possible because you are recording the interference pattern. If you want to have an interference pattern, you should be able to record the amplitude and the phase. Amplitude and phase means you need a coherent wave. Only the coherent wave is capable of recording or preserving an amplitude and phase and retrieving back also. That kind of facility was not available until 1960. Until then, holography did not exist. In fact, Gabor tried using holographic, he constructed a hologram using a sodium vapor lamp, carefully prepared sodium vapor lamp. He did it. So, he was able to show that idea works, and then people have virtually forgotten. When laser came in, then the whole thing got a new life, and because of this one, it became an important technology from 1960 up to 2000. I would say for 40 years, it was the most fascinating subject, most fascinating research and technology where we were all involved, and after 2000, somehow it was slowly forgotten due to so many other reasons, and then it's almost gone now. You don't have the holographic plates. People have gone to the next stage, that is using a computer generated holography that is also is capable of giving something very real, three-dimensional image. So, people have gone into that one. However, in spite of all this one, if we have an occasion to see a proper holographic museum which is there in Eiffel Tower and also in London Museum, please go and see. Only when you see in reality a good quality hologram, you will see the immense beauty of holographic technique, immense technicality of holographic technique. Now, with this introduction, let us just go into the details of how holography is done, how it is reconstructed. Let us start with this picture. The first one represents the holographic construction, that is something like taking first photography. All that you need is a laser. The laser is split up into two. You see the BS represents beam splitter. It cuts or it divides the light into 5:1. That is one part to the reference beam which goes straight into a reflector, one reflector mirror one, another reflector mirror one, and then it falls on a lens. The lens just expands the beam and allows to fall on the photographic plate which is kept here at the bottom. This is called the reference beam. There is another beam which is 5 times stronger, which falls on the mirror on the top. Then again it goes straight line. You have another lens. This lens expands the laser beam, and this laser beam falls on an object. The object can be anything, or it can be your mobile, or it can be anything which is stationary. You cannot take the photography of a person employing this technique. For that you need another technique that is called pulsed hologram, which I will come back to this later. Right now, employing this technique, you can take only a fixed non-moving object. Okay, let us assume all these are done. Then look at this picture. you will have a scattered beam from the object. That beam is called object beam. It will always produce a spherical wavefront. A part of the wavefront will fall on the holographic plate shown there. That is called the object beam, and from the bottom with the lowest mirror there, the reference beam will go as a parallel wavefront, and that also will fall on the holographic plate. That means there are two types of wave. One is a reference beam, the other one is object beam. These two beams will interfere on the special type of holographic plate. Remember, holographic plate is again a photographic plate. Only thing is, it has a grain size so fine that it is capable of preserving, it is capable of producing or preserving the diffraction pattern, it is capable of preserving the interference pattern between the object beam and the reference beam. That means, the step 1 in doing construction of a hologram, all that you need is producing interference between object beam and the reference beam. Reference beam is just it's like a standard. Only with respect to this reference beam you are going to see the changes in the amplitude and the phase coming from the scattered object beam. That is all. That is the first step. Then take the plate. There are certain special type of very special chemicals in which you always process it. You put it like this one and wait for certain time, it will do certain reaction, and after some time you take the plate, just leave it for a while. So, all the whatever is the solution, it drip away, just wash it with neat pure water, just leave it, do not show it, do not heat it or anything, just leave it for some time. The water, the moisture will evaporate, you will have a clean dry plate. Then all that you have to is look at the second diagram. You stand the processed plate in the same place where it was kept in the step 1. That is done now. Then shine the laser beam. See, in the construction I have sent the laser beam like this. You can do in the same fashion, or you can send the other way. I have sent the laser beam just in the opposite direction. Then what would happen is, this laser beam will fall on the interference pattern produced and preserved in the holographic plate. The interference pattern will be alternate dark and bright fringes. You must have seen this one in any interference fringes. Only difference is, this will be a random dark and bright fringes. It will not be something like a interference pattern of a single slit or double slit. It will be randomized one, because the object will not produce a very normal orderly wavelets, it will produce a random wavelets. In whatever case, the laser beam will fall on the processed holographic plate, then it will produce a diffraction pattern. That diffraction pattern, one will be on the left side, it will produce the real 3-dimensional image of the object, that is called virtual image, which you can see it. How can you see it? Just go to the other side, see wherever I have shown the eye. If you put your eye there, you will see the virtual image in real 3 dimension. On the other side, the same side, just on equal angle, you will see a real image, which will be just an inverted image. I do not want to go into the detail, it will be an inverted image. Now, under this condition, you would be able to see the real 3-dimensional image of the object. Unfortunately, I do not have a holographic plate. Otherwise, I could easily show that one and it will be a sight to see later. Maybe I would try to get a video program and I can show you to see the immense beauty of a hologram. I can explain now what is the very important thing about this one. The hologram in the 3-dimensional image, what you will see funny is this one. Now, look at this one. Suppose you have a row of people, first row, second row, third row. Imagine when we take a group photograph, we always say all those who are in the short just come to the front, all those who are in the tall go to the back. Then when we take a click, you will see all of them. Just imagine, suppose you have taken a tall man in the front and there is a short man somewhere here hidden behind that one. In ordinary photograph, can you just turn like this one, try to see the person hidden by a tall, hefty person? You cannot. It is not possible at all. On the other hand, in the holographic plate, you can do extremely very well. You have a tall person, behind him, let us imagine you have a short and thin person. The one who is in the front is a tall, hefty person. Then all that you have to do is in a holographic plate, shine the laser, then tilt the plate, or if you can move here, you can see the hidden person in this angle, or you lean over like this one, you can see the hidden person from there. That is called the real test for 3-dimensional effect. That is possible only with the holographic plate. Another interesting thing is, as I told you, suppose you have taken the whole thing in a holographic plate made of glass, drop it, take every piece, do the same thing instead of a full plate holograph, put the small plate, a very small plate, the broken plate. It can be very disorderly broken. And then if you put this one, do the same experiment. Even in a very small broken holographic plate, you will see the complete image. Only difference is the image may not be so very well resolved. The resolution and the clarity may not be so good. You may not have enough intensity, but you will have all the effect of 3-dimensional impact. Only thing is the clarity and the resolution will be poor. This is what we call lensless photography. Why? Look at this one, the construction part. You have a laser, it has been split up into two, and then you have a lens to allow the big beam fall on the object. We have not put the lens between the object and the photographic plate. We have not put anywhere that one, the object beam, whereas in the reference beam that is a different story, you are going to just expand it. Since you do not have the lens between the object and the holographic plate, what is happening is every part of the holographic plate is getting the information about every part of the object beam. That means the whole object has been preserved in every part of the holographic plate. This is not true in regular photography. In regular photography, which is with which you are very familiar, you have a camera. In the camera, you have a lens. The lens will be between the photographic plate. Here is a lens, here is a photographic plate, here is object. The lens will always capture the image and do the inversion, and it will do, the head will go here, tail, the leg of person will be here, in between different parts of the body will be recorded. So, only a part of the object will be recorded in one portion of the photographic plate. This is the problem with the conventional ordinary 2-dimensional photography. In the 3-dimensional lensless photography, the photographic plate or the special holographic plate will receive the information from every part of the object, will receive it. That is why even after breaking into 100 small pieces, I am not joking, we have done all these experiments, even in very, very tiny plate you can see the complete image. Only thing is it will not be so beautiful or not so good. Okay, that is all the importance about the holographic construction and reconstruction. I have not said anything about the real image. If you have ever seen, all that you need is, if you have a high power laser, very good quality laser, after expanding it, put the plate on the real image, you can put a paper, you can see the real very beautiful, very well defined image of the object also. That is something you can capture it. The image that you can capture is called the real image. The image that you can see is called the virtual image. You cannot capture on the paper or on a cloth. You can just see that one. Now, the most interesting thing is, you can immediately see on the reconstruction, this is the typical example of diffraction. You know, you must have, in fact, I have explained so many times, I send the laser beam, I have a grating. Then if I have a grating, I will have two images, +1, -1, +2, -2. That is a property of diffraction, which we have seen so many times. This is what you are getting it. I have a plate, I have one image, at equal angle you will see the real image. That is to show that what we have preserved in the photographic plate, holographic plate, is an interference between the object beam and the laser beam, reference beam. That is the first step. During the reconstruction, when we want to see the image, the process what we do is just a diffraction. So, here is interference, here is diffraction. Only both put together produces holography. Up to now, I have set an ideal condition. Immediately you could ask me, if the object keeps moving or if the object is breathing, what would happen? If the object is breathing, you will have one image after another image. The images would confuse, would blur away the interference pattern. So, in all holography, you need a vibration free table, and the object should be kept really fixed, really firm and clamped on the table. That is first step. Not only that, you see the laser, you cannot use any laser. For example, you cannot use nitrogen laser or excimer laser or a neodymium mag laser for all these kind of purpose. Neodymium mag laser, of course, you can use it. Nitrogen laser, excimer laser, they are very high power laser, but the coherence property is very low. The best laser, even semiconductor laser is useless for this one, the coherence is low. The best laser for this is a helium neon laser, which is in the red wavelength 633 nanometer. The power is about, typically what we use, about 5 milliwatt. You can have 10 milliwatt, 50 milliwatt. If you have a 50 milliwatt, you can have a very, very big object. Then you can see a very big building or a very big structure. You can shine all the light, and then whatever is scattered is capable of producing a very beautiful picture. For example, people have taken the Venus picture, Venus, you know, very beautiful, Venus of de Milo, very beautiful picture, and also the Pieta, Michelangelo's Pieta, that kind of rugged, very beautiful, marvelous architecture, stone architecture, sculpture has been photographed using this kind of laser and a holographic technique, and this is unbelievably beautiful when you see it in reality. This has another important thing. if you ever want to see the holography of a real man, what you can do? Go for a pulsed hologram. Take a pulsed hologram, that is, you do the whole thing with a neodymium laser, give one shot that is coherent enough, and also before the person changes his position, the whole operation will be done. So, if you employ a pulsed and very coherent laser, typical example being neodymium laser, you can take the holograph of a real person. These are the two major artistic applications of laser. We use mostly for certain engineering application, which I will take it up in the subsequent lecture. Thank you very much.